Okay, so let's do a problem now where it would actually be pretty hard to solve with a graph and would take a really long time to make a table. So here we have two high schools. Post Fall High School in Idaho has 1,160 students and is growing by 22 students per year. So I'm just going to make a little note to myself. That's plus 22 per year. So that'll be 22 times the years. And if I go down here, it says X represents years. So this is going to be plus 22X. Richmond High School in Indiana has 1,900 students and is shrinking by 15 students per year. So that's going to be minus 15 per year. So minus 15X. And then when I look at the starting population, that's going to be my constant. So when I write out these equations for Post Falls High School, I'm going to have Y, which is the population, equals 22x, so that's 22 times the number of years, plus 1,160. For Richmond High School, they start with 1,000, Y equals 1,900 students. I'm losing, made a little mistake, that should be a plus. Looks like it's going to let me erase that, but that should be plus 1,160. Sorry about that. And then for this one, we have 1,900 minus, and they're losing 15 students per year, so 15x. Now I have my two equations, and since a table and a graph would really be unwieldy, we're going to use the equal values method to solve this. So I want to know what year they're both this, or when their population is the same. So when are these two expressions equal? So let's type those in. I'm going to clean this up a little bit. So let's type in the equation that we're going to solve. And that will be 22x plus 1,160 equals 1,900 minus 15x. So I'm going to use what I know. I'm going to subtract values from both sides so that I isolate my variable. And then when I get all my x's on one side and my constants on the other, I'll divide to figure out what a single x would be. Once I've solved for x, then what I need to do is plug that back into one of my equations to figure out what the population will be at that time. So once I know the time, the number of years, I plug that in for x, and then I solve for y.